Hello, my name is Orbiter, and I'm your engineer, which will get you into orbit, or teach you the ways of the engineer to get you into orbit. Okay, this is going to be split into two parts. One is the building of the rocket, this is very important, and two, the launching of the rocket and how to get up into orbit. Okay, let's start in the VAB and we can start our engineering ourselves into orbit. Okay, so first off, you have to start off with the payload. What are you going to get up into orbit? Let's say you want to get Command Pod Mark 1 up there. Good enough. I'll try to keep this. I'm in sandbox mode, by the way, and I'll be trying to keep this to the parts you have in career mode, and hopefully that you've unlocked at this time. Right, now we want a parachute to gearing our Kerbal back safely. Use the Mark 16, not the XL, because the XL is ridiculously too large for this rocket. Now, say you want to get science up in orbit, so get the junior science pod out, or the materials bay as it is also known. Then get the goo canisters. Let's put two of them on there for good measure. Okay, now that's your payload. That is what you need to get into orbit. And what are the challenges? What makes it hard to get up into orbit? Well, you've got two factors. One, atmosphere. The atmosphere will cause drag on your rocket, causing it to slow down. And the second thing is gravity. It's constantly pulling you down, bringing you down. And you have to overcome those factors through engineering. And the way we're going to do this, first off, is go to structural, and you should have already unlocked it, the TR-188 stack decoupler. Stick him under there. And now we can build the rocket parts. Well, first off, you need some fuel. So get the FLT400 fuel tank. Then you'll need a rocket engine. And use the LV909 engine. The reason why I'm using this one, if you right click on it, you've got these numbers, engine ISP. 300 in ASL, that's atmosphere, and 390 in vacuum. Now if I hover over these, the LV45 has only 370 in the vacuum. That's lower, and this engine will be using in the vacuum. The reason is because this part of the stage is the one that's going to go into space. This is the part that is going to actually get into orbit. And that is what you need to do. Now the next stage, and you see here as well, I've got this mod here called Kerbal Engineering Redux mod. You can download it, it's easy to install, just follow the instructions. It's a handy engineer's tool. Some people call it cheating, but not really. You can do this by trial and error, or by looking at the tutorial like this, and learn how to do it, but this is how most engineers would do it. You could calculate these by yourself, by the way. All the numbers are in these parts. Alright, delta V is 2444. It's not enough to get us into space. And the next number you need to know is the thrust to weight ratio, which is 1.2. That means this will actually launch off the launch pad, if we did launch it. Now we want to do our second stage. This is the part that's going to get us into orbit when we're out of the atmosphere. So the next stage, we'll make another stack decoupler under the LV909 engine and go to the fuel tanks and get this one, the FLT800 fuel tank. Now stick two of them on the rocket as such, go to the engines, and this is the engine of my choice. You can use this one, it has a better thrust, but this one has thrust vectoring, which means it can steer a rocket, and that helps you out loads. Trust me, I'm an engineer. Now stick that under the rocket, and it's given us this. Right, it's given us 5,272 meters per second, but if we click atmospherics, you'll see it's under our target, which is 4,500 meters per second. So how are we going to overcome that? Well, quite simple actually. I'll leave that on. You go to structural. Now pick this, the TT38K radial decoupler. If you don't have that, and you may have this, the TT70 radial decoupler, choose that. Either one will be satisfactory. I'm going to use that one because I'm used to using that one. Put about 4 of these on there. Make sure your angle snap is on. And once they're on, go back to your rocket engines. Choose this, the RT10 solid fuel booster, and stick that on the side of the decoupler. Make sure you get them aligned correctly. Yep. Now, if we look at this, we're still in atmospherics. Oh, let's just check the staging so we get these numbers correct. Right, our main engine is firing after these. We want them all to fire at the same time. So drag it down. Now that staging is correct. Always make sure your staging is correct. Very important. Now that is correct. If we look at the stats, we've got 5,537. That is a lot more than what we need. So if I right click on one of these, you can reduce the amount of solid fuel you have. And I suggest you bring it down to 4,600. That's good enough. That's over what you need. You don't need any more of that. It also gives you extra fuel to perhaps get in higher orbit if you want to, and get extra science. Now let's have a look at our thrust to weight ratio. 6. That's a bit too high. So if we reduce that, let's get it down to 3. I don't think we need it any more than that. That's perfect. And we're still to V is still at 4,600 meters per second. Right. This rocket looks like it's going to be unstable on the launch pad because it's not being held up by anything. So let's shift and click. Scroll the mouse wheel down and bring him down. Place him there. And what I suggest you do is add some TT18A launch stability enhancers. Now if you want to save costs, you can put just 2 on there. 2. 1 will do. I only want 2, please. 2. Make sure it's not going to hit the solid fuel boosters. And that, ladies and gentlemen, is your rocket. That is what is going to get you into orbit. So let's name this craft. What should we call it? Should call it the Engineer's Orbiter. We'll save that. One last little check. Okay, make sure your staging is correct. The last thing you want to go is your parachute. Yep. That will decouple from the rocket. That rocket will fire. Let's start from the end. Okay, decouple, fire all your engines. Yes. Then the solid fuel boosters, when they're spent, they'll be decoupled. When the main rocket is gone, empty, will decouple. Then you will thrust into your orbit stage. Once that's done, you'll deorbit and decouple your main payload. Then deploy your parachute and float safely down to the surface. One last thing, check your Kerbal. If you can, make sure you've got Jebediah or any other Kerbal which is a pilot, because that'll help you loads in controlling the rocket with the SAS or stability. I forgot what SAS stands for now. I'm sure it's your command and control. Advanced reaction wheel. Advanced inline stabilizer. Like that. It'll keep your rocket going in one direction, but you can only do so with a pilot. Okay, let's save that and launch. I'll meet you on the launch pad. And here we are, guys, on the launch pad. We're ready to rock and roll, rumble up into space in our rocket. Okay, so what do we need to know? Well, we're in the thickest part of the atmosphere. If you look at this dial here, that's the thickest part. As soon as we get up to 10 kilometers, as soon as we get through the thickest part of the atmosphere, it's then we'll be turning over to do our gravity turn, as you may or may not know. And first off, as I said, you need to get up to 10 kilometers, which is to get through the thickest part of the atmosphere, to get rid of that worst of the drag that is caused by the atmosphere. Then as soon as you get up to that 10 kilometers, turning over, and this is where you'll be fighting gravity. You'll be going sideways. And what the idea is to get enough sideways velocity that you eventually get up into orbit. And so that's our task. So the two things you need to remember. One, you need a speed of 2,300 meters per second. And you remember I said you need to get 4,500 meters per second? Well, you need all that fuel to get through the atmosphere. And that's NASA. That's what the problems people who build rockets like NASA have. Okay, so you know the basics. At 10 kilometers, we turn it over to the east, as you see on the nav pole, to 90 degrees. Then we'll watch our apoapsis. You see this number here. You won't have this unless you have the Kerbal Redux mod, but you can check in the map and it will give you the details, the height of your apoapsis. So you need not worry if you have not got this mod. Now I'm going to bring up my Kerbal Engineer, and I've got my vessel information here, which tells me how much delta V we have, how much is remaining, so I can keep an eye on it. You can keep an eye on it, and hopefully understand the engineering behind our rocket. Okay, so enough for talking. This is to get into orbit, so let's go. Now, full thrust. Press T to engage your SAS. Make sure this one's clicked, stability assist. So as soon as you turn your rocket, you'll head only in that direction, with any luck. So in 5, 4, 3, 2, 1, press the space bar, and let's engineer our orbit. Now let's thrust down a bit, because the solid rocket boosters are going to give us enough of a boost. I think 2/3 throttle will be perfect. Okay, let's ditch them and go to full thrust. Now we've lost a bit of speed there. That's not too bad. As soon as we've lost a bit more fuel, we'll get up to speed. If you want to, you could go back and do an engineer's refinement of your design. And we're not doing too bad. A little tip: do not go over 250 meters per second until you're 10 kilometers up, because otherwise you'll be fighting drag too much and you'll lose a lot more velocity, lose a lot more fuel than you need to. And I'll say it will keep control of our speed. Yeah, we're not in 250, we don't have to thrust down yet. It's all about balance, this is. It's an art in itself, as well as engineering and science. Okay, we're coming close to 200. Now we're up 10 kilometers. So we can slowly turn right or east. And the reason for that is if I click orbit, you can see we're already traveling right. And that's because the planet is rotating. So anyway, as soon as you get to this 90 degree mark, stop. There. Yes, the planet is rotating. So even though you're standing on the planet, you're traveling at, or is it 140 meters per second, I believe, on Kerbin. Probably a bit more on Earth. Now, as we're traveling sideways, let's press M. You can come in here, click on the AP here, and it'll show you your apoapsis, which is 30 meters per second. Now we're going to run out of fuel on our first stage soon. So if we go back out to map mode, the trick here is to get this over 70 kilometers. This is apoapsis. And once you've done so, that means you'll get in space. But for this demonstration, we're going to get to 100 kilometers. We're going to go for the full length. Okay. Fuels run out, press space again, and we've staged to our orbit stage. Now we're through the thickest part of the atmosphere. We're in the thinnest layer now, so the drag is greatly reduced. Now there's two things you could do here. You can carry on going this way until you get to 100 kilometers, or you can go further sideways, flatten out your trajectory to follow this Retrograde vector, which is on the nav ball, and keep on checking your map until you get to 100 kilometers. Now this can take a bit of time. It's generally advised to keep your time to apoapsis under a minute. Now we're not going to bother with that because this is just a tutorial on how to get into orbit, maybe even your first orbit. Now once you get to 100 kilometers, press X. That'll kill your rocket's engine. And now all you have to do is wait. Make a sandwich, have a cup of tea, or a cup of coffee, depending on your preference. Right, it's now that you're in space, that's what the music indicates. You can do a couple of things. If you're available in your tracking station, add a maneuver node. Now this is handy to show you how your rocket fares. Say you thrust forward, add your apoapsis, which is what you're going to be doing. You will increase your periapsis height. And if you carry on doing this and wait until these almost switch, and that is your orbit. As soon as these two, your apoapsis and your periapsis, switch to 90 degrees from your current apoapsis, then that means you'll be able to get into orbit. Now let's have a look at this. Estimated burn, 57 seconds. My general rule of thumb is burn 30 seconds before you get to your apoapsis and 30 seconds after, and you should get into orbit, at least with this design. So let's follow those instructions. Turn over to your maneuver node, or if you haven't got maneuver node capabilities, go to this line here, which is the horizon line of the planet, as seen by here, and 30 seconds before your apoapsis, which we've passed. Press Z to go full thrust. Now this is going to upset our orbit a little bit, but not too much. We'll get away with it. As I said, this is a tutorial. If you want to get it perfect, well, you don't have to get it perfect. As long as you get into orbit, it doesn't matter if your orbit is 100 kilometers by 70, unless your contract in the game states that you have to get to that. You do not have to get to that. And all we're doing is getting into orbit. Now if you saw it, it's going to, I believe the maneuver node is just about 900 meters per second or such. I should have checked beforehand. Alright, race reduced thrust. Don't worry if the maneuver node goes off track there. As long as this number is going down. Oh, it's going up now. Click X. Kill the maneuver node. And let's see what we've got. Now, we got 122 kilometers by 95. Now, that is not perfect, but it is an orbit. And in actual fact, this is perfect because you can get up into orbit and you can perfect your orbit using maneuvers. But this is not the tutorial for that. This is for you to get into orbit only. So let's get materials to science materials bay. We won't actually get science because it's sandbox mode. And let's say you got all your science. All your science is done. You want to getting it back safely now. So how do you get out of orbit? Well, actually, it's quite simple. It's the reverse of getting into orbit. So, let's create a maneuver node to show you what I mean. So we land on the day side. Let's create a maneuver node over here. Oh. And for some reason the game has stopped giving me maneuver node permissions. Let's see if going in and out of map will work. No, okay. We'll have to do this old style. Now let's hit the time accelerate. About here, I believe. Cannot time warp when you're below 12,120 kilometers. No problem. Okay, as soon as you're over here, come out to warp. Now, I'm going to point the rocket, as they would call it, retrograde, the opposite direction to which you're traveling in your orbit. Now, if I come into map view and start thrusting the rocket up, watch, the opposite side of my orbit is going down. And this is the most efficient way of getting out of orbit. Let's land in the desert here. Now because the drag of the atmosphere is going to cause this to reduce and hopefully land into the desert. Now that is how you get into orbit and deorbit. That is all you need to know. It is very simple. There's no messing about. This is the engineer's guide on how to get into orbit. Now, as we descend through the atmosphere, let's stage, because we do not need that rocket stage anymore. Well guys, that is not how you land. Apparently we needed extra parachutes, and that's the cool thing about engineering. You learn from your mistakes. So, if you want to learn more, I'll be more tutorials coming your way. We'll have one on going to the moon. We'll have one on how to land on the moon, how to engineer your own moon landing, and we'll also be able to be doing a tutorial on rendezvous with a space station or another spacecraft, and even docking, and maybe even a tutorial on how to get to another planet. So with me and Jebediah here, thanks for watching. Hit that like button, hit that subscribe button so you'll get instant updates on when these videos are out. Trust me, I'm an engineer.